In this video, I will be graphing polynomial functions from factored form and then using those graphs to solve polynomial inequalities. Let's do a little bit of review from the work we did together in Unit 2, Topic 2, Polynomials. When we looked at the polynomials unit, we looked at end behavior. And when we looked at end behavior, we considered two things. We considered the degree of a polynomial, and we considered the leading coefficient. We looked at whether the degree was an even degree polynomial, like x squared, x to the fourth, or if it was an odd degree polynomial, x to the third, x to the fifth, and so on. If it was an even degree polynomial and a positive leading coefficient, we know that the end behavior went up, up. If it was an even degree polynomial and a negative leading coefficient, like negative x squared, we knew that no matter what happened in the middle, the right and left side would go down. Now, for odd degrees, things like x cubed and x to the fifth, if we had a positive leading coefficient, it would look like this, going down to negative infinity on the left and up to positive infinity on the right. Now, it could be like a line. It could be a little more fancy like this. Just like, this one could have been like... And if we have a negative leading coefficient, it would look like this. We also looked at multiplicity in this unit. If we had a 0, like a polynomial, and it was like y equals x minus 2 squared, we know that the degree here is 2. The leading coefficient is 1. So we know it's going to look like a parabola. It's going to have up, up, and behavior. But because this root is squared at 2, 1, 2, it would be tangent. Similarly, if we had y equals x minus 2 cubed, now the degree is 3, and the leading coefficient is still 1, so it's down, up. But because it's cubed, we have a change in concavity at 2. And it looks like this. We need to remember this information when attempting the problems on pages 4 and 5. So let's take a look. On page 4, we're given some graphs, and we're asked to determine which of the answer choices could be the function that's graphed. So the first one here at number 4, we've got, I notice I've got up, up, and behavior. Both go to infinity. So that tells me it's going to have a even degree and a positive leading coefficient. So immediately I look at my answer choices, and I'm going to cross off B because B is a negative leading coefficient. B has a degree of 4 because 2, 3, 4. So if I add those up, it's 4. So that one works. 4, and this one's only 3, so it's definitely not going to be D. So now I'm looking between B and C, and I'm looking at the graph, and I notice that the graph is tangent at this x-intercept at -4. So I want this factor to be squared, the x plus 4, because it's going to give me the x-intercept of -4, and because it's squared, it's a double, so I know my answer is B. Number 5. I look at the graph for number 5, and I notice that the end behaviors go in opposite directions, which tells me it must be an odd degree polynomial. And because on the left, it goes up, and on the right, it goes down, I know it's going to have a negative leading coefficient. So I'm immediately going to eliminate A and B because they have positive leading coefficients. I also see that I have single zeros at -2, 0, and 2 because the graph just crosses those. Nothing happens. There's no tangent point there. So I look here, and actually D, 2, 3, 4, the answer has to be C, which makes sense because I have 0 at 0, -3, and 2, and they're single zeros. Pause the video and work on number 6 on your own. Hopefully for number 6, you notice that both ends of the graphs go up, so it has to be a positive leading coefficient, even degree, and immediately you eliminated answer choice C and answer choice D. Answer choice D is eliminated because 2, plus 2. Oh, wait, no, it's not. I'm a liar. That's a 2 there. So this is degree 6. So it's still in the running. Let's look at what we got. I've got zeros at -2 and 3, and they are both double zeros. So these are single zeros at -2 and 3. So I'm going to eliminate A. That's +2 and -3. So that I'm going to eliminate B. Let me just double check here. This is a double zero at -2 and a double zero at 3. And then I've got some imaginary zeros that I don't really care about, but the answer is going to be D. Let's take a look at page 5. Page 5 is going to require us to know what the graph looks like, or at least have a brief idea in order to solve the inequality. And we're always looking for where they are greater than, less than, greater than or equal to, or less than or equal to 0. So for number 7, we're given the function g of x, and we're asked, where is g greater than 0? I'm going to highlight where g is greater than 0. Now you'll notice I am not highlighting, well, I kind of missed. I'm not going to highlight -2. -2 is not being highlighted. So like right here, not highlighting that. So from -infinity to -2, and notice that I'm using open intervals. And also then again from -2 to +2, because that's where the function is above the x-axis. Where is g of x less than or equal to 0? Well, it's equal to 0 right there at -2, and then also from 2 down to infinity. And noticing I'm actually highlighting the 2. So I'm going to say -2, and then close bracket 2 to infinity. Let's take a look at number 8. We're given the function h of x, and the first thing we're looking for is where h of x is less than or equal to 0. So again, I'm going to take all the points on the x-axis, because that's where the function is equal to 0. And I'm also going to take the point below the x-axis. All right, so now I'm going to write that's one interval from -3 to 4. Inclusive. Where is the function greater than 0? Oops, I thought I changed. Here's where the function is greater than 0. So I'm going to say this function is greater than 0 from -infinity to -3, not including -3. And you can use the little u if you want to make a union, 4 to infinity. The 6 problems below are going to require us to graph the inequality before we consider its solution set. So let's take a look at a few of them together, and then I'm going to leave you to do some of them on your own, and you will have to show me a graph to receive credit. So let's take a look at number 9. Number 9, I see 3 single roots. I see them at 4. I'm not even going to put like a y-axis down. Nobody cares about the y-axis. At -4, -1, I'm going to put that one next, put them in order, and 3. And these are all single roots. This is a third degree polynomial. So if I multiply this together, it would be x to the third, and there's like a 1 here. So I know that this graph would look nice, smooth. There we go. Okay, single zeros. Where is it greater than or equal to 0? Between -1 and -4 inclusive, and 3 to infinity. Number 11. So number 11, there's an 8 here. Not really a big deal. I just have to remember it's a positive leading coefficient. And I've got 2, the degree is 4 because 2 plus 1 plus 1 is 4. So it's going to go up, up. Let's get the zeros down. So my first zero is actually -2, and that's, I want to remember, that's like a single zero. Then I've got 3, which is also a single zero, and then I've got 5, which is a double zero. I'm going to draw that one first. That's not a super great drawing, but you get the point. So there's my double zero, and then this has to come up here. So it's going to come down. Remember, I can't add any additional crossings. And that's a decent enough graph for me to answer this question. When is it less than or equal to 0? So between -2 and 3, but then also at 5. Okay, let's do number 13. Number 13 has a negative leading coefficient, and its degree is 2, 3, 4. So it's going to go down, down. Let's get the zeros on here. I'm going to have -7. Now, I've got a double 0 at 0 because it's just x squared, and 4. And I remember it's going down, down, and 0 is the double. So it's going to come, and then when it comes to 0, oh, that's kind of wiggly. That's okay. Again, I'm looking for where is this greater than or equal to 0. So now, again, I'm looking above the x-axis and including those, including all 3 of these. And then I'm also including this. So -7 to 4 is my interval. You should produce graphs for 10, 12, and 14 on your own, but I will list the final answer so you can check your work. But if you don't have graphs, you will not receive full credit on this assignment. Now, I want to point out, I can't go from 0 to infinity here because it's not equal to 0. So I have to write these as 2 separate intervals. Even though when you make your graph, you'll see that it could, like if this was an equal to 0, I could just say 0 to infinity. And that's what actually happens here. When you make the graph for 14, you might think it's 2, but because we're including the point at 1, it's just going to be 0 to 5. Again, you must have graphs for 9, 10, and 4, or for 10, 12, and 14 to receive full credit.